We already know that in our hard disk, the smallest storage unit is called a block. Next, we will discuss the topic of how our so-called files stored on a hard disk are mapped onto these blocks. A good allocation method will improve the performance of hardware and I/O. It's not hard to imagine that a well-placed algorithm will affect the distance and speed of the read-write heads movement during reading and writing. Next, we will introduce 3 strategies for allocation: contiguous allocations, linked allocations, and indexed allocation. The first method of allocation is contiguous allocation. In this method, each file occupies a group of continuous blocks. This way of storage is optimized for file searching because once we know the starting point and the length of the file, we can access the entire file continuously. Therefore, it supports both sequential and random access methods. We can directly jump to the starting point of the file and read the file data either randomly or in sequence. Since it only requires recording the file's starting position and size, its directory structure is the simplest, requiring only 2 integer numbers. However, this design has some drawbacks. Firstly, this design can lead to external fragmentation over time as the available space becomes increasingly fragmented. These fragmented spaces are scattered across the disk. Even if there is enough space, the discontinuity makes it increasingly difficult to find a sufficiently large contiguous space to store files. Additionally, if the exact size of the file is unknown, the system cannot determine how much contiguous space to reserve. Allocating too much or too little space can affect the performance of our file system. Finally, most files dynamically increase or decrease in size. With contiguous allocation, since files are placed in continuous blocks, if the following block is occupied by another file, the original file cannot dynamically adjust its size. Therefore, even for a minor expansion under this allocation strategy, we might need to move the entire file to another location on the disk, which is quite inefficient. Here, let's look at a simple example. Let's assume a target directory contains only 5 files: count, tr, mail, list, and f. In this directory, we only need to record the file name, the starting point of storage, and the length of the file. For example, let's consider the file mail, whose starting point is 19. This means it began storing data from the block with index 19. The file size of mail is shown as 6 in the directory, indicating it requires 6 blocks for storage. Since the allocation is contiguous, the data is stored continuously. Mail will occupy 6 continuous blocks from block 19 to block 24 to store all its data. Once we find the starting block and the number of blocks required for the file through the directory, we can quickly identify the location of this mail on the hard disk. In this example, the blocks inside the hard disk have index numbers. These index numbers are generated when we format the partition.